Hey there, in this video we are talking about mathematical expressions in C++, and this covers sections 3.1 and 3.2 in the Gaddis C++ book. So here we are starting chapter 3, and I think the main point of this video is computers are for computing. That's what they were invented for originally, to do a whole lot of repetitive, maybe complex mathematical calculations. It's a very essential part of how computers work and how the CPUs are set up. So we ought to know how to interface with that, and fortunately C++ makes that very straightforward. Okay, arithmetic operators, right? Operators that combine two numbers and produce another number in some way. So C++ has all the basic arithmetic operators. There's addition with the plus sign, there's subtraction with the minus sign. For multiplication, we use the asterisk, you probably know that in computing, and for division, we use the slash symbol. So for what it's worth, on a basic keyboard, right, there is this part on the right that's called the number pad, and it has all the digits, and the plus, minus, times, divide are all located really close to that, so you can very easily enter complicated mathematical stuff when you need to. So there it is, right over there. Okay, so the next question is, if you have a complicated expression and you have all these things built into it, you have adding and subtracting and multiplying and dividing, exactly what is the order in which that happens? And fortunately, the answer to that is exactly the same way as normal mathematical writing. C++ was set up to match that exactly, so hopefully you know that. The arithmetic order of operations is just like normal math writing, right? So what that means is, if you have all four operations there, it's going to do the multiplying and dividing first from left to right in the expression, and once it's all done with that, the CPU is going to do all the adding and subtracting from left to right. And that's just normal math order of operations. Now, if you don't like that, of course, you can enter parentheses to group components of it and say, we need you to do this part first, right? You can use parentheses anywhere you want like that. Now, in normal math writing, you can use square brackets, you can use curly braces for that kind of thing. You cannot do that in C++. You must use parentheses and nothing else. You can nest parentheses. You can have parentheses inside other parentheses. That's perfectly fine, but that is the only symbol that you can use for grouping mathematical expressions. Now think about fractions, right? Complex fractions are probably going to need more parentheses around the numerator and the denominator. So if you have a normal fraction in math writing, which we cannot do in C++ because everything has to be written in one line, but in normal math writing, if you have a fraction, that has implied grouping as part of it. It's saying, do all the calculations on the top in the numerator, then do all the calculations in the bottom, and then at the end you can divide. So since in C++ we're going to have to be writing our expressions all in one line, to get that grouping happening, the part that's supposed to be the numerator you're going to have to put in parentheses, and the part that's supposed to be the denominator you're going to have to put in parentheses separately to make that same action happening. Right? You sort of get that for free in standard math writing with a fraction bar. Here we don't get that for free. Similarly, juxtaposition is not recognized, right? And juxtaposition means putting two things right next to each other in math. So if I have a variable A and a variable B and I put them right next to each other in math, that implies multiplying automatically. I think that was done because multiplying is probably the most common operation of all, and therefore you just get it for free in your writing. But in C++, you don't get it for free. If you want multiplying, you've got to put down the asterisk symbol in every single place that multiplying is happening. Right? Juxtaposition is not recognized. So the appendix has, the book has an appendix. It's either Appendix B or Appendix C in older edition that has a full list of all the operators in C++. I mean, here we're only talking about 4. The full story is that C++ has about 50 different symbolic operators. Now, they're not all arithmetic operators. There's a whole bunch of different kinds of operators that we'll learn more and more about in future weeks. But you might want to keep an eye on Appendix B because all 50 of those operators need to have some kind of position in the precedence list, in the order of operations list. Right? In normal math, you're accustomed to just having 4 operations that you need to handle. But for the full 50-fold or so operators in C++, there's a much larger precedence table. And as you add more operators, you might want to keep an eye on that to see which ones happen first. That's up in the appendix. Okay, so here is the tricky thing that you're going to have to kind of keep in mind. As a beginning programmer, this might be a little surprising, right? We have two different classes of numeric data types. We have the integer type family, and we also have the floating point type family, and they are, handled differently, and therefore you're going to have to keep that in mind. Neither one of them work exactly the same way that you would expect mathematical numbers to work with. I think in math you kind of assume that you can have infinite decimal places if you need to, or you can have infinite scaling numbers upwards if you need to. And since the computing system is always limited with a finite space for any particular data, that's not going to be a possibility in either direction. Okay, so the CPUs actually have different circuitry for handling integer mathematics versus floating point mathematics, right? Different actual circuits, parts of the CPU. And the place where this is really going to become visible is specifically in the division operation. You're really going to have to be careful about that when you read it, okay? So here's the story for integer division. Integer division gives you an integer quotient without any remainder, right? If you're dividing two integer values, the circuitry that does that just hands you back an integer quotient, no remainder, no decimal places. Okay, so for example, in C++, if you just write 8/3, 8 divide 3, what types of numbers are the 8 and the 3? Well, those are integers. If you write a number like that, it's treated as an integer literal. That's in the last video or so. And that comes back as just 2, right? Now, if you did a hand division with that, what you'd see probably on a piece of paper is you'd get a quotient of 2 and also a remainder of 2, right? Because 3 times 2 gives you 6 and there's 2 left over. So normally I'd say that's a quotient 2, remainder 2, but for integer division, all you get back is just the quotient. I think in math probably you'd call that truncation, right? Just throwing away the remainder part. But in some sense in computing it's even simpler. You're doing integer division, you just get the integer quotient, that's the end. That's the end of the story. The integer remainder is simply not visible. Now, if you want to access the remainder, we'll talk about that on the next slide. Anyway, but let's talk about, before we see that, let's talk about division for floating point values, right? Now, floating point division, if you're dividing one or more floating point values, that will result in a decimal value that's rounded off to fit the allocated floating point data type. So different example here, right? It almost looks like the same, but what I have here is if I wrote in C++ 8./3, and the point immediately tells C++ that this is a floating point value. I could have written 8.0, maybe you'd prefer to see that, but I've at least got to get the point in the writing because that's the indicator that I've got a floating point literal here. So when C++ sees that, right, that division is going to treat those numbers as floating points, use the circuitry path that does floating point arithmetic, and that's going to come back with a decimal value. And for argument's sake, if I store that in a single precision floating point variable, the value will be 2.6666667, right? Notice that that's rounded off for the 8 precision places or so for a single precision float. Now, you and I know that the real mathematical value is 2.6666 repeating forever. So this is not exactly the same number. It's pretty close though, and as we said before, that's always going to be happening with any kind of floating point math. It's going to have to be rounded off to fit in the available space. Now, a little detail on that is in that example, I'm assuming that we stored it in a single precision float. Now, naturally, that actually produces a double precision value, and that goes on 15 or 16 places before it gets cut off. But I didn't want to use that much space on the slide. Technically, that's actually what 8.divided/3 normally turns into. Okay, so two very different activities, two very different actions for division, depending on whether the operands are both integers or if one of them is floating point. Now, let's think a little bit more about that integer division, right? So integer division comes back with just the quotient, and the remainder part is totally invisible. But you can access if you want to, and here's how. It's called the modulus operator. Here's a new operator just for that, the modulus operator. And this is a term that we use in a math class if you get to this point in your math training. so not too surprising. For integer division, specifically, the remainder can be returned with this modulus operator that looks like the percentage symbol. I think we're using that because it's got a slash in it, kind of like the division symbol. That's why we used it. So for example, 25 modulus 3, right, 25% 3 is what it looks like, has the value of 1. Because if you're dividing 3 into 25, 3 goes in 8 times, and 8 times 3 is 24, and there's 1 left over. So the remainder, I would say, or the modulus, is 1. Here's a new operator, right? You've got to talk about where is it in the order of operations. Well, since this is basically a division thing, this has the same order of operations as multiplying and dividing. So when the CPU gets to that stage in your expression, now it's going to go left to right in the expression and do all the multiplies, divides, and moduli that it runs into from left to right. Here's an example of why you would want to use that. So one use of that is to determine if one number is evenly divisible by another, right? If one number evenly divides into another number, then the modulus will be 0. There will be no remainder. So consider, like, if I wrote this in C++, if I had a variable called num, and let's say that's an integer, and I wrote integer, num modulus 2. So if num is actually even, that is divisible by 2 with no remainder, and the result will be 0. But if num is odd, then that remainder will be 1, right? So you could compute this, and if the result is 0, num had to be even. If the result is 1, num had to be odd. So there's probably more examples of things why you'd want to use the modulus operator, but there's a very simple one just to determine whether a number is even or odd. Or more generally, right, if you're doing a division and the remainder is 0, then that was an even division. And we might need to use that in future assignments or future test programming problems, things like that. I think in a math class, if you see this idea of the modulus operator, they're probably going to write it out as a word. They're going to write MOD in a math class. But in C++, we do use the percentage sign, kind of like a little scrambled up division symbol for that. So keep that in mind as an option. Okay, so here's a couple of review slides. And if I was in person, I would have my classes, if I was in an in-person class, I would have my students kind of yell out the answers to me. So here are some mathematical expressions that you might see in C++. And over here on the right, we're going to come up with the value here. I'll do the first one right now, 5 plus 2 times 4. So of course, the order of operations says the multiplying is going to happen first. The CPU is going to do 2 times 4 and come up with 8. And then it's going to come through and it's going to do 5 plus 8, and I think it's going to get 13. There you go. So consider pausing the video in a second and taking a piece of paper and seeing if you can come up with the answers to the rest of them. In particular here, right, be careful when you run into division. There's several of these have division operators, and every time you run into one, you got to think really carefully, are these integers that are being divided? Because in that case, I'm just going to get an integer quotient back, no decimal. But if one of these is a floating point value, then we're going to be doing floating point math and potentially come back with a decimal. So that for division problems, that's probably the first thing you want to think about is what kind of division is this, integer or floating point? So pause this, see if you can write down the answers, and we'll present them in a second and see if we agree. Okay, do you have answers to that? Hopefully so. So the next one here is going to come out to be negative 12. First of all, negative 12 times 2 is negative 24. And then the CPU does 8 minus 24, that's negative 16. Right? And then it adds 4 and it comes up with a negative 12. Now here come the division problems. In this third one, the first thing that happens is 9 divided by 2. What kind of division is that, integer or floating point? Well, that's integer, right? 9 and 2 are both integer literals. So I'm not going to get any decimal value out of that. 9 divided by 2 has a quotient of 4. 2 goes into 9 4 times is what that is. And then, having figured that out, the CPU comes through and does 3 plus 4, and it's going to get 7. Now here's the fourth one, right? Again, division. What kind of division is happening here? Integer or floating point? Well, that's actually floating point division, because 1.0, that's a floating point literal. So the floating point division path gets triggered, and it actually does 1.0 divided by 4, comes up with the decimal 0.25 on that. Then it does addition, 0.25 plus 6 is, well, it's 6.25, right? Here's one that's tricky, right? The fifth one down here, really tricky. So again, division, 3 divided by 9. What kind of division? Well, it's integer division. How many times does 9 go into 3? Well, 0. Actually, if you did that division by hand, you'd get 0 for the quotient, and you'd have a remainder of 3, but that gets tossed away. So that actually comes out to be 0. And then once you get that 0, the CPU adds 1.2 plus 0, and it comes out to be, surprise, surprise, 1.2. Okay, so if you have integer division, you have a small number divided by a large number, that actually comes out to be 0 all the time. So be a little careful of that. And the last one down here, obviously it's got that percent symbol for modulus. That is the first thing that happens because the modulus order of operations is just like multiplying, dividing. Right? It comes before any add subtracts. So here, 17 mod 2, well, 2 goes into 17 8 times. That gives you 16, and there's a remainder of 1 left over. So 17 mod 2 is actually 1. Then the CPU comes through and does 4 plus 1 for 5, and then 5 minus 3 for 2. Okay, hopefully that's a pretty good review. Let's do a little more. Okay, none of those examples had parentheses in them, right? And probably in programming math, you're actually going to be seeing a lot of parentheses. So we should just make sure that we're familiar with how that works in just standard math. So here's our grouping review with parentheses. Again, can't use brackets for this, can't use curly braces, they're used for other things. So if you saw the first one here in C++, of course, the whole point of parentheses is to say, do what's inside of me first. That's it. That's all parentheses mean. And obviously inside the parentheses you have 5 plus 2, that gives you 7, and then 7 times 4 on the CPU, I think will give you 28. So once again, consider pausing the video, taking a piece of paper, seeing if you can predict what the results will be. Again, some of these have division in them, so think very carefully when that happens. Are we doing integer division and just get an integer quotient? Or are we doing floating point division and actually having to deal with decimals? So at this point, pause the video and restart it when you think you have your answers. Okay, hopefully you have answers to this. Let's see if we agree. So in the second one, I think 6 minus 2 happens first, that's 4. Then the multiplying happens, and 12 times 4 is 48. And then 8 plus the 48, I think, will be 56, right? Good. Okay, third one down. Thing in parentheses happens first, of course. 7 minus 3 is 4, okay? Now you're doing division. What kind of division? Well, it's integer division. The 10 is an integer. The 4 is an integer, right? The result of subtracting 2 integers. So we're going to be doing integer division. 10 divided by 4. 4 goes into 10 2 times, and the remainder just gets tossed aside. So 2. Great. In the fourth one down there, 4 plus 17 gives you 21. Right? Then you do 21 mod 2. So 2 goes into 21 10 times, the remainder of 1. You get 1. And then you have to do 1 minus 9, and I think you get negative 8. Great. And this last one down here, so the first parentheses give you 11. The second parentheses give you 2. And then working left to right, you're going to do all the multiplying, dividing left to right. So 11 times 2 is 22. Divide that by 3. Now remember, that's integer division. You get an integer 22, I think. You have the integer 3, and 3 goes into 22 7 times. And you get 7. No decimals there. Okay, so hopefully that's pretty clear. Not any different with the parentheses, really. Mostly the thing that's different here is, again, how the division works if it's integer versus floating point. And then there's also a modulus symbol that might show up. Those are probably the new things. One more review slide here. Okay, so those all had literal numbers in them, but of course a lot of the time we're going to have variables in our writings. Let's think about that. Here are some expressions that you might see in a math book or a science book, and we're just going to think for a minute about if you need to translate one of those common things into C++, what is it going to look like? So this first one, right, 6, what you're looking at there is 6 times b. You get the multiplying for free because of the juxtaposition. So in C++, you don't get that for free. You can't write down 6b. You're going to have to write the times symbol to indicate the multiplying. So that actually would be 6 times b. Now, again, b is not really the best name for a variable in C++. We would prefer to turn that into a full-blown name, but I don't know what that refers to right here. So on this slide, I'm not going to do that. So once again, pause the video here and try to write down what you think these expressions will look like in C++, and then restart in a second and see if we agree. Okay, do you have answers to that? So again, the second one there indicates multiplying, of course. Parentheses do not indicate multiplying. All they mean is do what's inside of me first, that's it. So again, with the second one, you are going to have to write an asterisk to get 3 multiplied by 12. Same story with the third one, right? You're going to have a whole bunch of asterisks here. You're going to have 4 star x star y to get those things multiplied. Now with the fourth one, right, you're seeing a fraction there. We're going to write that whole thing out in a line, and as we said a couple minutes back, you get grouping for free with this piece of math writing. The a plus b has to get added first on top. Once you have that, then you can do top divided by 2. So as we write that out in one line, you're going to have to put parentheses around the numerator to make sure that the a plus b happens first, right? Hypothetically, if someone left out the parentheses, what would happen there is you do b divided by 2 first because of the order of operations, and then you'd add a. And it is clearly a different ordering than what the math writing means. So you have to be careful about that and make sure you get parentheses around your numerator. With the last one, same story, right? Except you got to put it around both the top and the bottom. So here, you'd have to put the numerator m1 minus m naught, and those are legitimate variable names, frankly. Put those in parentheses, put the denominator s divided by n in parentheses, and then finally you have a division symbol there. And these are all common things. That I think the second to last one, obviously, is how you compute an average. This last item here, I think comes out of a statistics class, if I recall. So common things you'd see in math or science, and this is what they'd have to look like in C++. So hopefully that's helpful. Okay, so that's the start of chapter 3 for us, right? The primary story is that you can write math in C++ mostly the same way you normally do in any other science class. The details that are a little bit different are to be careful about integer math versus floating point math, particularly with division. And you also have the modulus symbol in order to recover the integer remainder when you need that. And you're probably going to be writing a whole lot of parentheses as we translate stuff out into one line because you don't have the opportunity to write fractions one on top of the other like you do in a math class. Okay, so at this point with my classes, when we were in person, we would do this lab 3.1 titled Working with the Sin Statement. Remember, that's the object in C++ that does character input, allows a user running the program to type something into the keyboard and save that data in a variable. So this is actually the first time that we are directly working with that in a lab, so that's probably a good thing to practice. And what happens in this lab is we have a program that should take user input for maybe like at a store, a number of items that someone is buying, the price per item, and output a total bill for that. Now, once you're using SYN and once the user can type in information, there's a whole heck of a lot of different things that the user could possibly type in. So you want to start testing your programs more rigorously. I would have my students write a test script, as you can see here. And in this case, I would want to have at least 3 different test cases, maybe like 5 or 6, right? And I would want to test it with some small numbers and some larger numbers and simple numbers I can do in my head and complex numbers that I would need a calculator for, and make sure that the program actually gives the correct results for a wide variety of different possible inputs, right? And again, you write the test script first, you figure that out mentally, then you write the program, and then you test it 1, 2, 3 times, 1 time per test case, confirm that what you thought mentally should be the answer is actually what the program is giving for output. And that's what we do all the time. So that's going to be pretty good practice. Next time when we come back in chapter 3, we're going to be looking at more details. Now that we have SYN on the table and we can do both input and output, we're going to be looking at more details that C++ has for formatting that input and that output in different ways to make it look nice to the end user. And that should help us with our interfaces and help us make nice tables when we have a lot of data. And that should be useful a lot of the time going forward. So I'll see you then for that.